First things first, we've got to talk about the concepts that are the absolute foundation of SRE. These are the tools that let you stop guessing about reliability and start making really smart, data-driven decisions. Think of this as learning the basic language of SRE.
Okay, so everything in SRE starts with measurement, and that's your SLI, the service level indicator. It is the raw number you're actually tracking. It could be something like the request success rate of your API, which you can see in cloud monitoring, or maybe something a bit more specific like 99th percentile latency. It's just the pure, simple data telling you how your service is performing right this second.
But, a raw number by itself isn't super helpful. You need a target to aim for. And that's your SLO, the service level objective. This is the goal your team sets internally for that SLI. So, for example, your team might sit down and agree, hey, we want 99.9% of all our API requests to be successful over the next 30 days. That's your internal promise for what good enough actually looks like.
Now, an SLA is a whole different beast. This is the formal contractual promise you make to your users, often with some serious financial penalties if you break it. And that's exactly why your internal SLO is always stricter. It gives your team a safety buffer before you even get close to violating that external promise.
And that brings us to the real magic, the crucial piece that connects reliability to how fast you can release new features, the error budget. It's actually super simple. It's just 100% minus your SLO. It's the amount of unreliability that you've all agreed is acceptable.
So, what's so cool about this slide is how it turns an abstract percentage into something you can actually feel. A 99.9% availability SLO isn't just a number. It gives you a concrete error budget of about 43 minutes of downtime per month. This is time you can literally spend on things like risky new deployments, planned maintenance, or, those unexpected outages.
And this quote just brilliantly illustrates the real power of this whole framework. Error budgets totally transform how you manage releases. It's no longer about sitting in meetings, subjectively debating risk. It becomes a simple, data-driven process. Is there budget left? Ship it. Is the budget all used up? Okay, time to freeze feature releases and focus on making things more reliable.
So now that we have a solid framework for measuring and talking about reliability, let's see how that applies to the next key area for the exam, managing the entire service lifecycle, especially when it comes to capacity and autoscaling.
On Google Cloud, services like CloudRun and GKE Autopilot have some incredibly powerful features for this. You can set them up to scale all the way down to 0, so you're not paying for idle resources. But you can also set hard upper limits. That way, a sudden traffic spike doesn't turn into a surprise giant bill at the end of the month.
For GKE specifically, it is absolutely critical for the exam that you understand the two ways to scale. You've got the horizontal pod autoscaler, or HPA, which adds more copies of your service to handle more load. Then you have the vertical pod autoscaler, VPA, which makes each individual copy smarter by giving it the right amount of CPU and memory. They solve different problems, and yep, they can even work together.
And here's why that's such a big deal. In a real e-commerce example, a team originally just guessed that their pods needed about 500 millicores of CPU. But after letting the vertical pod autoscaler watch the actual usage, it recommended just 200. Making that one change cut their per pod costs by 30%. That's a huge saving, just by getting rid of waste.
But hey, let's be real. Even with the best capacity planning in the world, problems are going to happen. So what do you do when an incident strikes? The exam is definitely going to test you on how you can minimize the impact, the blast radius, and fix things lightning fast.
Just look at this timeline from a real incident. It shows the power of SRE in action. A new deployment goes out and immediately starts causing errors. But just 2 minutes later, a fast burn alert, which is designed to detect a really rapid drop in your error budget, fires and pages the on-call engineer. And only 5 minutes after that, they've shifted traffic back to the old stable version. The total time users were impacted, just 7 minutes. That's incredible.
So for the exam, you need to remember that Google Cloud gives you a whole bunch of tools for these super fast rollbacks. In CloudRun, you can instantly split traffic between different versions. If you're using Cloud Deploy, you get one-click rollbacks for your whole delivery pipeline. And with GKE, you have native commands like Coup Control, Rollout, Undo. Knowing which tool to grab for the job is really key.
All right, for our last section, let's talk about the cultural side of things. Because SRE is way more than just a bunch of tools and metrics. It's a whole culture, a set of practices that are all about continuous improvement.
One of the biggest SRE practices you've got to know is this relentless focus on reducing toil.
So what is toil? It's any operational work that's manual, super repetitive, and could be automated. Think manually approving every deployment or updating config files by hand. The goal is to automate all that stuff away so that your engineers can focus on valuable, long-term engineering work instead.
Now, chaos engineering sounds a little scary, doesn't it? But it's not about breaking things just for fun. It's about running controlled experiments to find weaknesses in your system before your users do. For example, you could use CloudRun to send just 1% of your traffic to a faulty version just to make sure your alerting works, or maybe use Cloud Service Mesh and GKE to inject some network delays to see how your services handle it.
And after an incident is over, the work isn't done. The SRE practice of a blameless postmortem is so important. The focus is never ever on who messed up. It's always on what can we improve in the system to make sure this kind of thing doesn't happen again. It's all about learning from failure to make the whole system stronger. Okay, let's wrap this all up. What's the one key idea, the main blueprint you should keep in mind as you prepare for this section of the exam?
Remember this as you study. SRE is not about getting to 100% uptime, because that's impossible. It's about giving you a framework to have an objective, data-driven conversation about the trade-offs between moving fast and staying stable. It gives your teams the data they need to move fast, but to do it safely. Good luck with your studies.